open this raster, of course using my file opening button. And this is my DEM, Digital Elevation Model of the mangroves. And here are individual trees, and you can actually see them, and the lighter the color, the higher they are, higher elevation. And there are the darker regions, which is the ground. So I can think about it as I have a terrain model, which is all the stuff on top of the terrain, and a surface model, which is the surface on which the terrain is sitting, so my baseline. And if I want to know the tree's height, I need to know the difference between the top of the tree and the base. And I can do that using this button over here called the information button. And if I press on the top of this, what I can see here is 11.05 versus the ground, which is 8.5. I can take a bit of a shortcut here, and everywhere I'm looking is about 8.3, 8.5, 8.2. I could subtract the surface layer from my raster using the raster calculator from before. Right, so I can calculate a new output layer and call it DTM, my digital terrain model of mangroves. I'm going to put it on my desktop because that's where I put everything. And I'm going to call it DM minus a surface, which we said is about 8.4. Okay, so I can create something like that. And it's thinking about it. Okay, calculation complete. And here is my new layer. And if I investigate it now, I'll see that the height of the mangrove is 2.4, 2.4, 2.8. That's pretty much the height of the mangroves in Western Port. My next step is to measure the parameters for the allometric equation that Charlotte developed. And we're going to do that by, first of all, determining an area. So I need a polygon, and I can always work out the area of the polygon because I'm working in a geographic reference system. As you recall, I put in a new shapefile layer, a polygon. I'm going to call it mangrove area. Save it somewhere. I see that you guys all do the same, which is it's saved somewhere, you never find it again. So I trained you well in making a mess. I'm going to edit this, remember, and add a feature. And here is my polygon. I want to grab about 10 trees, right? And you're going to have to make a decision what you do about trees on the line. Maybe trees that are on one line, on two sides, you count them, and if they're on the other sides, don't count them. That's a common way of dealing with boundaries. So I can't see anything with my polygon. So first of all, I'm going to turn the fill off. I'm going to make a transparent fill here. Okay, so I just have this line, and of course that's one thing you need to report in your reports is this line. Remember when we finished editing? Okay, first of all, this line is like pretty weak. I'm gonna give this stroke, it's currently black, I'm gonna make the stroke color brown or yellow and make that wider. Okay, and now I've got a nice bright box. Okay, big box of unidentified color. I'm going to save that. Here's my mangrove area, and in my mangrove area I need to know the biomass. If I know the biomass per meter square of this, I can work out how much carbon is stored in the above ground biomass of Western Port in mangroves. So for that I need to find out the dimensions of this polygon, and I can do that. So this is a vector, right? And in vector I have some geometry tools and analysis tools and research tools and data management tools and geoprocessing tools, all of that. Okay, so I can work out geometries. So I can add geometry attributes to my attribute table. So I can ask it to calculate using the layer CRS. I can ask it to add like the area of, this is So I'm on the wrong layer here. And first of all, I'm going to show you this attribute table. And here's my ID. And when I go to my vector, I just need to go to my geometry tools and add geometry attributes. And I want to add it to my mangrove area. I wonder why it's not letting me. Hold on. Okay, so, oh, it is my one, mangrove area, sorry. Calculated using the layer CRS. So using knowing latitudes and longitudes, it's going to calculate my geometries. I'm going to run, and when I go back to my additional info, which I don't need to see on the map, but if I open this attribute table, it's going to tell me the area is 4.47 times e to the negative 8, and that is in degrees. So if you multiply that by about 112 kilometers, you're going to get kilometer square. So you'll have to convert those, okay, because it's in degrees. I'll show you another shortcut. You can convert this to a different type of CRS. Okay, I can use, for example, the Australian grid, which has a different coordinate system that uses meters. So I could use that, but I'll show you that after I finish the next thing. So for now we know the area in degrees of latitude, and we'll work from that to kilometer square in a minute in Excel. So here's my DTM of the mangrove, the terrain, the actual measurements of height, and I see that wide is about 4.2 meters, which is the highest mangroves we have at this site. But when I'm in here, I need to identify individual trees. I'll zoom in to see better. So I can, it's kind of hard, and you'll see that you kind of need to make a call sometimes. But whether this is a tree, and this is a tree, and this is a tree, is something to work out. And what I'm going to do is use this measure line. Okay, I can measure area if you need canopy area. So first of all, you can measure the area of your polygon. Sorry. Instead of adding that, hold on, stop. And this one already converts, so 426 square meters. And that's based on not Cartesian, but ellipsoidal projections. Okay, so new. So if I want to know the canopy area here of this tree over there, I can do that. It's 12.648 meters, and so on and so forth. And the height of it, remember I'm using my information thing, is 2.97, and so on and so forth for all your trees. Create an Excel spreadsheet. I think that's all we needed.